Hello everyone. So I will give you some tips about the quadratic equation and nature of roots. And we all know that the quadratic equation looks like this: x square plus bx plus c, where a, b, c are constant, and these are normally real numbers. So, and if you talk about the b constant, then b minus b by a equal to alpha plus beta. Alpha and beta are roots. Okay, and then another c by a, this will give product of roots. Okay, and if we talk about the types of roots, then these are the complex roots, real and equal roots, real and distinct roots. There are three types of roots there will be, and we will talk about later. So, nature of roots. So the nature of roots mainly described by the determinant. If we are able to find the discriminant, and which is denoted by d, so we will be able to uh, so we will easily will be stated that this equation has the real roots, real and equal roots, and complex roots. So these are the some conditions, like if d is less than 0, then it has the no real graphical representations, and the curve has not intersect the x-axis. It means that it has not real solutions. It has the imaginary solutions. And if d equal to 0, it will have the real and equal roots. And if you know that the imaginary roots, a complex number, imaginary roots are always coexist in by the like conjugate. Like if we told x square plus 1 equal to 0, then its roots equal to x equal to plus minus iota. So this is can't be equal to only iota, and if iota will be the roots, then obviously minus iota will be also there will be the roots. And if you talk about the d will be the square of the rational numbers, and it means that d is the perfect square, then it will be the roots will be become the rational number, and it is not the square of the rational numbers, then it will be the irrational roots. Okay, now we will see by the graphical representations of the roots. So, and here will be the like this is the vertex. The vertex will be represented by the minus b by 2a and minus d by 4a. Okay, and alpha beta are the two roots, and a is greater than 0, and if a is less than 0, then there will be the like this, the graph will be like this. Okay, and second type, and here d is the greater than 0, and roots will be the real and distinct. And by this graph is also seen that the roots are real and distinct. And if we talk about the if d equal to 0, then the roots will be equal, and like it will be the like the axis will be tangent of this curve. Okay, and it will not depend on the a greater than 0 or a less than 0. If a greater than 0, the graph look like this, and if a less than 0, then the graph look like this, a less than 0. Okay, so now if we talk about the imaginary roots, d less than 0, there will be the imaginary roots, and there will be two roots, and they will be the conjugate to each other. And if a greater than 0, then this graph will be there, and if a less than 0, this graph will be there. Okay, please remember these graphs. This is very easy. Now We will see the some examples like this: x square plus 2x plus 1. This is the x plus 1 whole square equal to 0, and this means x equal to plus minus 1, and this is the equal, but we have to find the natural roots. So we will calculate d equal to b square minus 4ac. Okay, so b equal to minus 2 का whole square minus 4ac, 1 into 1. Okay, so there will be 0, so roots will be equal. Okay, so roots will be what will the roots will be x equal to minus 1 and minus 1. And one thing I want to remember, it has two solutions, minus 1 and minus 1, but it has only one roots, but it has only one roots. Okay, so again, if you see about this has the two solutions and two roots, and this is also will be the have the two roots and two solutions. Solutions will be equal or distinct, but roots will be always distinct. And if a root has distinct, then we will be said the two roots and three roots like that. And if like the plus 1 and plus 1, then it has the two roots, but it has the two solutions. Okay, thank you.